Hello, my name's Paul Graham. I'm the founder of Graham Audio. What follows is an introductory video to a series of videos we're making about the Graham Audio range. In this first one, Derek Hughes talks about the BBC, his philosophy about electronics and building the loudspeakers, and about the whole of the Graham Audio range.
Well, my dad worked for the BBC research department in the acoustics section involved with loudspeaker design. So he was always bringing odd loudspeakers home, some of which I wish I'd kept, probably worth a fortune now. And also he tended to take me down to research department at weekends when there's no one else around. And so I had the opportunity to listen to top-level broadcast speakers in their listening room, right from probably age 13, 14 upwards. So that obviously sparked an interest. And it just went on from there, really. I mean, the ability to play with sort of ex-BBC gear and BBC gear that he borrowed and do recordings with that sort of equipment right from teenage years obviously was a huge advantage in terms of just being able to interface with that level of audio equipment. It was great fun. I mean, it's sort of go out boys' toys and grown-up toys as a teenager sort of thing. I mean, when I was sort of 14, 15, I was sort of borrowing studio tape recorders to record the local band at church and things like that, you know. So it was a bit different from normal. I mean, I also did music as well, which fitted really. I mean, it's all about reproducing music in the end. Yes, I did science. But of course, alongside that, I was soaking up all sorts of engineering information, which wasn't in the school curriculum at all. So it was a natural progression. And then when it came to career choices, I decided to join the BBC rather than go on to sort of uni. Because the BBC have got their own training school in Evesham. And there's two sort of streams to it called technical assistants, which I was, which is the engineering side, and technical operators who did things like vision and sound mixing and that sort of thing. So I went for the engineering side of it. And you went initially for 6 months there. Don't do it now, but there's 6 months of training out there. Just came back home at weekends. And then you did various blocks of training during the first sort of 3 or 4 years that you're at the BBC. To bring you up to what was called a Grade C engineering sort of qualification, which was the same level that people who did university degrees came in on. So it was reckoned to do the same level. And only we knew how equipment worked and they didn't. I went to television news because one of the guys at research I knew very well was talking to about what to do when I joined. And he said, you'll get a better grounding if you go into television because you'll be dealing with both sides of the industry, video and sound. And that was very good. The great thing about Alexandra Palace News Department was it was all engineers. So we got to do everything. We got, apart from maintenance stuff, we did sound mixing, we did vision mixing, we operated cameras in studios. So it was a really very rounded sort of job in terms of experience. But it was while I was working at Alexandra Palace that Spencer, my father, started designing speakers for himself rather than just for the BBC. He started off at the BBC as a mechanical engineer and got involved in building a lot of the microphones that they did. That was his starting point. And then went on to loudspeaker work. A thing called the PGS microphone. There's a new version of it called the 4038, which Coles make, very widely used ribbon microphone, still used. And he was involved with the original version. The BBC licensed the design to Coles. They changed the outside look of the thing, but the fundamentals were the same, yeah. There were some things which they only did in-house, particularly in the TV side of things. But in general, once a design was made, and they wanted it in any quantity, then they licensed it to outside companies to manufacture. So initially he got involved in machining, designing the mechanics, and then gradually drew more and more into the actual loudspeaker design, crossover design. And the initial pair he made were a fairly small box, about the same size as the LS59 actually. with an 8-inch driver and a Celestion tweeter. And I took a pair of these up to Alexandra Palace. Of course, all the BBC speakers at that time were big. Set these up in, I think, Studio B, and everyone was just knocked out with the quality. They just could not believe that a little speaker in a plain plywood box could come out with that sort of quality. One of the first people who actually was working at the BBC at the time was Paul Messenger, who writes a lot of audio stuff. And he was very bowled over. And so that was the start of my father's designing his own loudspeakers, and eventually obviously produced his own company. At the time he was working on the BBC LS55 loudspeaker development, which was the first major speaker to use Bextrine plastic as a comb material. And the BBC had been investigating plastics to use instead of paper for a little while. It was a very big investigation. I think that they looked at about 300 different plastics to use in comb materials and did experiments with them. They designed their own vacuum forming machine, designed their own moulds, and eventually came up with the loudspeaker, the bass driver, 12-inch bass driver in the LS55, an 8-inch mid-range. And the 8-inch mid-range in the 5.5, my father was sort of developing his own personal drive unit at the same time, sort of in parallel, effectively. So when he started that, obviously people had heard the ones I took to research department. He then made a 2 cubic foot one, which worked a bit better at the base end. And then friends of his research said, "Oh, could you build one for us?" So he built a couple of pairs for friends at research department. Then one of them took them to a local hi-fi shop who said, "We'd never heard anything like this before." And that it just ballooned from there. So you started off with very old loudspeakers like the LSU-10, which was a huge device with a coaxial 15-inch driver in it. They went on to the LS51, which is a 15-inch driver and Celestion tweeters to improve consistency and sort of levelling of the frequency response. Then he moved to the 5.5, which gave you, again, a level response, but improved the off-axis response and reduced coloration. So there was always a consistent aim and a gradual improvement in trying to achieve that aim effectively, I suppose, by using better materials and slightly different techniques. One of the loudspeakers to come out of BBC research, and probably the most famous, was the LS35A and LS35. This was a sort of almost a happy accident, because it came out of a development for modelling studios. And what research department did is build an 8th scale model of a studio, a lime Maida Vale, I think, was the first one. And they needed a loudspeaker which would go up to 8 times normal frequency. So everything had to be scaled acoustically, the absorption, the space, the loudspeaker output, the microphone ability to receive it was all scaled up by 8 times. And at some point, someone thought, well, I wonder what this little loudspeaker sounds like if we actually put proper music in it rather than just test signals, which is what they were using. So it was changed slightly, put in a different box. And lo and behold, it was thought, well, this isn't bad at all. And of course, there were more requirements in those days for things like small loudspeakers and outside broadcast settings, which at the moment, up to that time, had commercial speakers which weren't particularly good. So the LS35 and then subsequently the LS35A were born out of that 8th scale model work. The first studio to be actually designed from the model was at Pebble Mill, and was a roaring success, basically. It was, I think probably with some trepidation, is this actually going to work? If we scale up all these little bits and pieces in our model to a real studio, is it going to work? And it worked very well. To design a scale model studio, the big thing it brought is the cost element. So you could design all your little bits and pieces at 8th scale, put them in this model and test them before you spent out on design the real thing. So they designed small seats and things which had acoustic absorption at 8 times the frequency that they were expecting, and then they could design the seats and absorbers around the walls to those specifications. But it was all scaled up from the model. For this scale model, they had to invent all sorts of things. They had to design a tape recorder which would record up to 100 kilohertz. Microphones and loudspeakers did the same. And it was all done sort of electromechanically, not using computers at all. One of the things which was a hallmark of research department was innovation. And of course, in those days, the designs I'm talking about, computers just really didn't exist, or certainly not in any form that could be used for measurement. So they had to design all their own testing equipment, some of it based on equipment like Brew and Kerr and such, which was available. But there was a particular one designed for harmonic distortion measurement, which is an amazing piece of sort of original equipment, which could measure up down to the, I think, 7th harmonic. And it was all mechanically driven. But there was, the innovators down at BBC Research often came up with these sort of groundbreaking products because it was a limitless supply of personnel and money to a great degree. So they just were given a project and they worked at it till they solved it. Situation which really you couldn't really reproduce commercially in these days, not to that extent anyway. Just to demonstrate the sort of abilities that they had down there, one of the times I was working, when I was at A-levels, I worked down there in the summer holidays, and they had their chief mathematician. We were sitting around, and it was in the early days of geostationary satellites. And someone said, well, I wonder how they work out, you know, how high to put them and all the trajectories. And basically he said, I think I might think about that. So he got a paper napkin out and scrawled this big equation on it and said, I think that's probably, you'll find that's probably how they did it. And it turns out it did. He just did it completely off the top of his head as a mathematician. And that's the level of expertise they had at a research department. One of the key aspects in a design is the design of the loudspeaker crossover. In other words, the splitting filter between the low frequency and the high frequency drivers, or with the LS55, low to mid and mid to high. And it's a very crucial part of the overall sound of the loudspeaker. Fundamentally, you have a crossover because no one drive unit will cover the entire audio spectrum. So the bigger drive units cover the bass end, smaller drive units cover the mid, even smaller drive units cover the sort of HF section, the tweeters. And getting a smooth blend between those different acoustic responses is the function of the crossover. The difficulty is that no loudspeaker drive unit is smooth or predictable in the areas where you need to cross it over. So when I approach a crossover design, I don't take what would be considered to be traditional responses, Butterworth, etc. I actually look at the drive units themselves and their acoustical and phase response, where I'm trying to marry them together and do what will be a blend of traditional and non-traditional design. The idea is to get a smooth response through the crossover region, and to do that you need to choose your crossover point looking at the drive units, and well, for example, the original LS55 crossed over at a frequency 400, I think. We've moved it very slightly because the particular drive units we've got perform better with that slightly different crossover point. To be slavish about the original one would have compromised the overall quality, as an example. In regard to crossover slopes, there's obviously a lot of debate about that. If you use a very, very high slope crossover, one of the downsides is that if you imagine a piece of music or an instrument which glides up in its frequency band, for the sake of argument, if you've got very, very sharp crossover, the output from the drive unit will jump from one to the other. And my experience is that this gives a slightly strange psychological effect. You're not expecting the position of an instrument to suddenly move. So in general, I use 18 or 12 dB an octave filters, roughly speaking. But the Q or the turnover corner of those frequencies is adjusted for a particular drive unit. This is one of the more complicated crossovers. This is for an LS55. So you've got base section, large series inductor and shunt capacitors. The mid-range and tweeter are fed with auto transformers, and these match the impedances of the original drive units and make it an easier loudspeaker to drive. The auto transformer will also enable you to adjust for different sensitivities of the drive units and match them together. I've used that technique for many years, and although it's a slightly more complicated way of making a crossover, it gives you much more flexibility to end up with a one which is easy to drive, a decent input impedance, and ability to change the sensitivity of drivers easily. Loudspeaker design and crossover design starts with the drive units. The process really is to choose a drive unit that you think will fit in terms of size, power handling, smoothness of response, and then measure that drive unit in a cabinet, plot response, and then start designing a crossover to marry the two drive units together. It's a mixture of processes. What I do is I measure the impedance of a drive unit, I import it into a simulation package, which I can then build a simulated crossover in. And that means I can show the effect of different component changes very easily without having to rebuild things. So that's the first step. And it gives you probably 80% of the way there, I'd have said, in terms of a design. It varies depending on the drive unit. And then I build it up in a physical form. At that point, you find the other 20% that you didn't get right, because computer modelling can only give you the response, the output of the information you put into it. And at that point, you haven't got all the information. So you're then designing with the drive unit and the crossover and the cabinet effects. And then I would then do a crossover network, go back to the simulator very often to sort of confirm that the changes I made were predictable. Not necessarily for that loudspeaker, but in doing that, you build up a catalogue, internal catalogue, as it were, of crossovers and how they function, which you can use in other designs. Throughout the loudspeaker range, we use air core chokes and polypropylene capacitors. The advantage of air core over ferrite or powder core is that it doesn't saturate. In other words, you can put as much power into it as you like, and the distortion will be as near to zero as is practicable. That's a crossover from an LS35, for example, and this is a crossover from an LS55. So although the scale's different, that's a 3-way apart from anything else, and with higher powered resistors in it, the principles behind it, the component type we use, is the same throughout the range. When we take on the BBC licenses, we try to stick to the fundamentals of the design, particularly cabinet size, cabinet shape, the way the cabinets are constructed is the main thing. We obviously do have the facility to make improvements where necessary, and power handling and smoothness of response are part of those. But we try to stay true to the essentials of the design. All the BBC monitors, whether they're small or big, the monitor concept is that you want to hear what the microphone hears without any interference or change. Now, obviously, any loudspeaker has got more imperfections than probably the rest of the audio chain put together, with microphones coming second. So any loudspeaker is going to have deficiencies. It's a question of balancing the deficiencies as best you can within a certain design and size. But the BBC's aim is always fidelity to the original sound rather than imposing any sonic character other than can be avoided because of the imperfections of loudspeakers. This is basically an experiment to see the best position vertically for the microphone from the bass end point of view. So what I'm trying to do is to get relative measurements in an correct position, front, side and back. And then I'll move it with the mic close. Because I've got this at home, I can then sort of interpolate other measurements I do on other speakers in non-ideal conditions. So I'm sort of calibrating the way of testing it, so I know it.
So you're calibrating the test routine
Effectively,
in
yes.
a known environment, so
Yeah.
you can interpolate it to an unknown environment.
Precisely so. I'm doing three. Apart from the long one, I'm doing on the baffle 100 millimetres and 200 millimetres. You do near field measurement, but because of the nature of dispersion, you'll get a rising response at the base end. So again, what I'm trying to do is do a near field and a far field. And I'll do it for the 6-inch and I'll do it for the 8-inch. So I can then construct an equaliser. So I'm measuring far field. I can then get a much more accurate, effective near field response. And he's moving this way. Yes, I've been asked whether I considered the LS55 to be the pinnacle of BBC loudspeaker design, and in many ways I believe it was. In terms of the use of the slots to aid dispersion, the smoothness of the frequency response, the low distortion, it was a very, very good loudspeaker. The only compromise was power handling. But apart from that, I think, yes, I think it was, my opinion is it's probably the best speaker that the BBC produced. And I think it's one of the best that we now produce. Yeah, in contrast to the 5.8 and 5.9, the LS55 uses a paper cone bass driver. The reason for this is that the crossover point at 400 Hz is well below the areas where paper starts to be inconsistent in sound quality. The BBC chose polypropylene for the 5.8 and 5.9 driver because it is then consistent up to 2 kHz for the 5.8 and 3 kHz for the 5.9. At those crossover points, you still get a consistent sound with polypropylene, whereas you wouldn't get as consistent a sound to that higher frequency with paper. In the context of the LS55 loudspeaker design, using a paper cone, which is a stiffer material, gives you better performance at the extreme bass end when the air load on the cone is greatest. Because we use a 400 Hz crossover point to the mid-range, it means that the irregularities introduced by a paper cone higher up in frequency are not important. By that time, we've crossed over to the polypropylene cone mid-range with a much smoother response at higher frequencies. The LS81, our latest loudspeaker, is very much a follow-on from the LS55 design, insofar as it uses virtually identical bass driver to the mid-range driver of the 5.5 and the same tweeter, albeit with a slightly different faceplate and grille. This enables it to have very much of the same quality characteristics of the 5.5, obviously not quite as extended at the bass end because of the smaller cabinet, but we've enabled it to have very similar monitor quality, and so far the reaction in the marketplace, as it were, has been extremely positive. The LS81 is a bit unusual configuration for these days insofar as it has a second tweeter. You could call it a super tweeter, I guess. The main thing it improves is the off-axis response, the dispersion at very high frequencies. The main tweeter's a 1-inch dome tweeter. The top one is a 3/4. So at frequencies above 10 kHz, it improves the dispersion of the overall loudspeaker. tweeter technology has changed. The early BBC speakers used what was eventually a Celestion HF 1300. It was previously made by GEC under another name, which I can't remember. And that was a hard phenolic dome, which was very good, but went up to about 13 kilohertz and then completely died. So it had limited high frequency extension. Wasn't particularly sensitive, wasn't particularly robust either. So, but things have moved on a lot. Again, just with bass drivers as well, although materials have changed, the fundamentals haven't changed. So you're looking at things like more efficiency, more power handling, smoother response. But, you know, the essentials of the way drivers are made haven't really changed particularly. I suppose with tweeters, the move from hard domes to soft domes was quite one of the biggest changes. Soft domes tended to give you better lower coloration, extended high frequency response. So there have been incremental changes rather than wholesale changes, I would have said. One of the questions we've been asked recently is why the LS58 and 59 only went up to 16 or so kilohertz. The reason is purely the availability of tweeters at the time. The LS58 was the first model to be made of those two, and it was designed as a high power replacement for the LS55. And the Audax 1.25" tweeter was the only one available at the time which would take that sort of power. And it stopped working at 16 kilohertz, which was no problem in the context of their design and what they wanted to use it for. And we used that in the LS59 just because the BBC used it in the LS59. It's got, so it gives you a more consistent top end between the two models. That's what the BBC were after. I mean, one of the big sort of BBC mantras really was reproducibility and consistency across different models and in different sort of studio situations. So using the same tweeter in both models just made sense from that point of view. I refer to the LS58 and the limitations of the Audax tweeter. We have actually made a change to a modification to that model, the 58S. There's two changes. Fundamentally, a tweeter that goes up higher in frequency and indeed is smoother in response. And also we've incorporated a diffraction slot, which was on the LS51 and the LS55. And this improves the off-axis response of the bass driver as well. The slots have been the subject of a lot of query and wonderment as to whether it works at all and why it should work. In essence, it's very simple. The smaller radiating surface is, the wider its dispersion. So a tweeter will have a very wide dispersion because it's a very small radiating surface. A bass driver will have gradually reducing dispersion as the frequency increases. By putting a slot in front of the bass driver, you're making the air outside, if you like, think it is narrower than it is. So therefore, the off-axis response is better than it is with the whole diameter of the driver visible. It has its drawbacks. Obviously, you're including a volume of air behind the baffle, and at a certain frequency, this will result in a big dip in the response. The trick is to put that dip outside or above the crossover point in the loudspeaker, which is what we've done. Yes, it is a rarity. I think it's a rarity because it doesn't look pretty, I suppose you could say, and obviously an awful lot of the audio industry, loudspeaker industry, how things look is crucial. And obviously in designing professional loudspeakers, your bias is towards how they sound rather than how they look, if I can put it as simply as that. So we would go for the slots on the LS55 because it gets a better result, not because it looks pretty. You can always put the grill on. It's a lot of people do listen with their eyes, as it were, with the aesthetics first and the sound afterwards. It's an interesting fact, which goes along with that in BBC Research listening room, they actually had a very lightweight acoustic curtain in front of the loudspeakers. So when they were doing comparisons and listening tests, they couldn't see the loudspeakers. The curtain was completely acoustically transparent, So there was no visual impairment of their judgment, if you like. They were just listening to the sound. On that curtain, there's actually a graded scale, and they were, that particular thing, they were working on, if they do crosstalk between left and right, how much it changes the image. There's an article about that, yeah. I've been asked which I prefer between the LS35 and the LS35A. The honest answer is the LS35. The reason for that is that was the first speaker that research built, following on from the modelling experiments. And they built that to have a response and sound quality the same as the other monitors that they were working on. The LS35A was a follower model. The design had been given to designs department in the BBC, who were responsible for actually putting boxes in studios, if you like. It was decided they needed to make it a bit more rugged, so they put a grille on the tweeter. They put felt around the tweeter because they recessed the baffle more to give more protection to the drive units and things like that. And they changed the sound balance slightly to make it more useful in outside broadcast situations and small studios. So it moved the 35A slightly away from the straightforward flat response monitor idea. So when we did the 35, I sort of put it back to that, as it were, if you like. So I sort of made the response how I perceived all the other monitors to be in terms of frequency balance. So that's the reason for preference. I've often been asked which is my favourite of the Graham Audio loudspeakers. And that's very difficult because, of course, you've got a great range from the LS3, LS35 as a small loudspeaker right up to through the LS55, LS51, the VO2. The fact that they are all very different sizes means that they fulfil slightly different functions in different places. I suppose overall I really enjoy working on the LS55 and I enjoy listening to it, which is unusual for a designer. There's not many loudspeakers I enjoy listening to, to be frank, even my own. So as far as the LS55 overall, I would have said, but they all have their place, and in different environments, home environments, studio environments, each one has its own place and is right for that environment. This is the Graham Audio VO2 Max. It's a four-way design, a sub-bass cabinet, reflex, and the top cabinet, a separate enclosure, two 10s working together, a 3-inch mid-range and a 1.5-inch tweeter. The crossovers are separate, one for the bass in the bass cabinet and then for the top cabinet. Having the cabinet separate is primarily a practical thing, as with the weight of the complete device it would be very difficult to move in one piece. It also gives a degree of isolation acoustically between the two cabinets. The advantage of a two-box design also is that the top part can be reconfigured as a full-range device for studio monitoring. From a technical point of view, the origins of this design were in some loudspeakers we made for the Royal Opera House in London for musical play-in to their performances. Out of that grew the original VO2, and now the VO2 Max, one step further in terms of size and power.